Um, Hello everyone, I'm Christopher Núñez, and the title of this research is 3D reconstruction of a bridge with concrete dama classification using deep learning. This presentation is divided in 5 parts. The first one is introductions, methodology, imaging processing, result, and conclusions. And the introductions is so important because in many countries, there are many bridges that are categorized as structural deficiencies due to, for example, natural disasters, aging, traffic loads. Well, natural disaster and traffic loads, I think we consider as external reasons. And also we have inadequate maintenance, and which is the most important, especially in my country. So therefore, we need to focus on preserve the structural integrity and functionality. But the problem is that we take a lot of time, or timely detections, measurements of damage elements are crucial because we need to maintain the infrastructure of a country. And why? Because infrastructure means communication between cities, means also economy of a country. And the main objective of this research is to get a 3D reconstruction of a bridge with a concrete dama classification system. As you can see in the right image, we can see in yellow parts the damage classification. Okay, we got the next table that we made by past research. As you can see, we consider 3 different scales. The first one, no damage, with no color. Moderate damage, orange, and then major damage, red. And also we consider the 5, or in my opinion, the 5 or the main 5 concrete damage. Those are corrosions, crack, efflorescency, exposed bars, and spoliation. So this is so important because, as you can see in the last image, this is, we have yellow part, right? So we consider as a moderate damage, the yellow or orange. So then we have the data acquisition, and we use UFV machine, Tron, and we consider an overlapping for overlap rates 60% vertical overlap and 30% horizontal overlap. And we consider a distance of 1 meter. Because of the ground, we need to optimize the ground sample distance. And you can see how we get the data in the superstructure, the overlapping, and the substructure. To the data training, the big problem that we got is the drone gave us an image with large pixels. So we need to resize this image into 228 pixels. So that's why, because we need to train the data. And we consider a validation of a 20%. So it also gave us a problem because when you cut the image, you lost the metadata of the image. So we need to get the metadata of the image and then put with the recreated image. So we use the case study in each bridge in my country. So we get 89 selected images. You can see the result of the data training with the 5 main concrete damage corrosion, cracks, efflorescency, exposed bar, spelling. You can see the loss and the accuracy of a training and the validation. We separate with epoch, the first one, and the third diff. And the data classification, I choose one of the example. You can see here at the middle, bottom middle. And then you can see the result for how can get the classification in corrosion, cracks, efflorescency, spelling, and exposed bar. You can see that we have a very good percent, no color 88%, so that means it's correct. And you can see the result of a breach with the image classification. And also you can see that we have like a rectangle forms because we need to resize the image or cut the image. But the problem is when you cut the image, you lost the metadata of the image. So we need to reconstruct every part of pixels and then get or bring the metadata to this new or reconstructed image. And finally, with a software or every software that can or use photogrammetry, you can reconstruct the breach. Finally, you can get the 3D reconstruction of a breach with concrete damage classification. Finally, I would like to mention the conclusions. The proposed methodology combines 3D reconstruction and deep learning for efficient breach inspection, providing an automated alternative that reduces time and cost compared to the traditional methods. You can read all the conclusions, but I would like to focus on the main conclusion that we need to do this because, for example, in my country, there is no register of all the breaches, and we can plan or I don't know how to reconstruct the breaches in our country and update how is the state of our breaches. So that is so important because, for example, in my country, the breaches have or I don't know was built 100 years ago. So that's a big problem because we don't have a 3D model, and we can plan how maintain the breach. That's why it's so important. How can I get a 3D reconstruction the current state of a breach? And that's all. Thank you. Thanks for coming.
Thank you so much. If you could please hang around. We'll try to take questions after the next speaker.